So if we look at resistors in parallel look slightly different from those in series. They're basically connected on top of each other rather than side by side. So if we have R1 and we have R2 connected in parallel like so. So there is more than one direction in which the electrical current can flow, and it also means that the total resistance is not as easy to calculate as it is in a series circuit. So in a series circuit, what we discussed at the start of the lesson was that if you've got two resistors side by side, then you just simply add them together to get what the total resistance is. And the effect of that is really just like drawing one resistor. So if you've got two resistors next to each other and you add them together in series, it's just like making that into one single resistor of a certain value. We can't do that though with R1 and R2, as we found through the experiment. With R1 and R2, we had to do something much more complicated. And we found that for resistors in series, resistors in parallel, we cannot simply add them together to find the total resistance. Because when we add resistors together to find the total resistance, what we're really doing is increasing the value. You know, the total resistance is always bigger than the values of the individual resistors in a series circuit. Always bigger. But what did you notice about the value of resistance when you connect two in parallel? What happens to it? It goes down, exactly. It decreases. So when we connect resistors in parallel, the overall, or the total resistance, decreases. And what we did was we got 1 divided by R1, we figured out what that was, and we did 1 divided by R2, figured out what that was, and added both of those values together. But we got a value that was different from the total resistance that we measured. But then when we did 1 divided by that number, what we got was a correlation, that they were almost exactly the same. So to calculate the total resistance in a parallel circuit, we use the following equation. It's 1 over RT. Remember that RT is your total resistance, so it's 1 divided by that number. It's not RT on this left-hand side of the equation like it is with series circuits. So as you'll see next lesson, that makes things a wee bit more difficult to calculate. And that will be equal to 1 over R1 plus 1 over R2. So if we consider the two resistors just like the ones we used in the experiment, just like the ones I've got at the top of the page here, then we're only looking at two resistors. But again, as with the series circuit, that goes on for however many resistors there are. You're never going to be asked to deal with more than 2 or 3. It's not going to be ever any more than that for calculating total resistance in parallel, but the equation still applies for however many resistors you might have. So a totally different equation for resistance in parallel, much more complicated looking, but now proven by experiment. And you'll also, another important thing to note is that when you connect resistors in parallel, the resistance always goes down, whereas in series it always goes up. So that kind of proves the need for having this additional equation for this. We can't just add them simply together because that would give us a bigger number. We're looking at smaller numbers, and that's how to calculate it out.